I am Radhakrishna, mathematics teacher. Today we are going to continue indefinite integration, the last lecture. We are going to revise all models with all different methods, integration by decomposition, substitution, by parts, etc. Okay, let us start the session. Integral 1 upon sin x plus sin 2x. Usually when sin x plus sin 2x is there, you will try to combine them by applying transformations. But here, even if you combine, you will get a product. Then what will you do? So, if you write sin 2x as 2 sin x cos x, 1 by sin x plus 2 sin x cos x dx. Now take sin x common from the denominator, you will get 1 upon sin x into 1 plus 2 cos x. Okay. Now you know that derivative of sin x is cos x, derivative of cos x is minus sin x. So if you have cos x in numerator, you can put sin x is equal to t. If you have sin x in numerator, you can put cos x is equal to t. But denominator should be completely in terms of t. So for that, we multiply and divide by sin x. Then derivative of cos x is minus sin x. We got sin x in numerator. So we should put cos x is equal to t. So denominator should be completely in terms of t. If you must divide by sin x, this sin x becomes sin square x. We can write as 1 minus cos square x into 1 plus 2 cos x. Okay. Now put cos x is equal to t. Then minus sin x dx is equal to dt. Then numerator will be minus dt, minus dt by 1 minus t square into 1 plus 2t. Okay. Now you can remove this minus sign by writing denominator as t square minus 1, and t square minus 1 can be factorized as t plus 1 into t minus 1. So it will be 1 upon t plus 1 into t minus 1 into 2t plus 1 dt. Now what is the method? We have to resolve this into partial fractions and integrate it. How to resolve into partial fractions? We have to take the fractions as a by t plus 1 plus b by t minus 1 plus c by 2t plus 1, and already I have explained how to find a, b, c quickly. You will get a by t plus 1. If you want a, you cover t plus 1 and put t is equal to minus 1, because this factor is becoming 0 for t is equal to minus 1. So cover this and put t is equal to minus 1 in the remaining. 1 by minus 2 into minus 1, minus 1 by 2 is the value of a. So minus 1 by 2 by t plus 1. Next, plus b by t minus 1. How to get b? You cover t minus 1 and put t is equal to 1 in the remaining. 1 by 1 plus 1 into 2 plus 1, that is 1 by 6. So b is 1 by 6 by t minus 1 plus c by 2t plus 1. Cover this 2t plus 1 and put t is equal to minus 1 by 2 in the remaining. Then this will be 1 by minus 1 by 2 plus 1, 1 by 2, minus 1 by 2 minus 1, minus 3 by 2. 1 by 2 into minus 3 by 2. How much? Minus 4 by 3. So this will be minus 4 by 3 by 2t plus 1. What is the integral of 1 by t plus 1? Log mod t plus 1. So, finally, the given integral is I is equal to, usually we denote every integral by I is equal to minus 1 by 2 log mod t plus 1 plus 1 by 6 into log mod t minus 1 next minus 4 by 3 into log mod 2t plus 1 by 2. Derivative of 2t plus 1 is 2, so we have to divide by 2. Then this 4 by 3 becomes 2 by 3 log mod 2t plus 1 plus c. That is the final answer, where t is equal to cos x. You can leave the answer in terms of t by writing where t is equal to cos x. Next question, integral root x sin x plus alpha upon root sin x minus alpha. Rationalizing the numerator, we get I is equal to rationalize numerator we have to multiply and divide by root sin x plus alpha, then numerator becomes sin x plus alpha, denominator will be square root of sin x plus alpha into sin x minus alpha. What is it? Sin x plus alpha into sin x minus alpha, sin square x minus sin square alpha. Dx. Now, let us expand the numerator and see. Sin x plus alpha is sin x cos alpha plus cos x sin alpha by root over sin square x minus sin square alpha. Now, alpha is constant, so cos alpha and sin alpha are constants. Let us separate into two integrals. In the first integral, we can take out cos alpha. Cos alpha integral sin x upon root over sin square x minus sin square alpha dx plus, in the second term sin alpha is constant, so take it out. Sin alpha integral cos x by root over sin square x minus sin square alpha. Now, this derivative of this sin x is the derivative of what? Minus cos x. If you can write the denominator in terms of cos x, then you can put cos x is equal to t and integrate it. How to write denominator in terms of cos x? You write sin square x as 1 minus cos square x and sin square alpha as 1 minus cos square alpha. Then that 1 will cancel, you will get cos alpha integral sin x dx by, this is 1 minus cos square x minus 1 minus cos square alpha, it will be cos square alpha minus cos square x dx, dx is already there. Next, plus in the second integral, numerator is cos x, it is the derivative of sin x, and denominator is in terms of sin x, sin alpha is constant. So, no need to change anything, write it as it is. sin alpha into cos x dx by root over sin square x minus sin square alpha. Okay. In the first integral we have to put cos x is equal to t, in the second integral sin x is equal to t, but we cannot put sin x is equal to t and cos x is equal to t at a time. So, you put cos x is equal to u and sin x is equal to v. Put cos x is equal to u, then differentiating we get minus sin x dx is equal to du. So, this numerator will be minus du and put sin x is equal to v, then its derivative is cos x dx is equal to dv. So, this numerator will become dv. So, now this is cos alpha integral minus du by root over cos square alpha minus u square plus sin alpha into numerator is dv by under root v square minus sin square alpha. The first integral is in the form of 1 by root over a square minus x square. We have the formula. Integral 1 by root over a square minus x square is sin inverse x by a. So, it is minus cos alpha into minus cos alpha into sin inverse of u by cos alpha. Now, I will directly substitute u. So, I will get cos x by cos alpha plus sin alpha into the second part. Integral 1 by x root over x square minus a square. What is the formula? Cos h inverse x by a, or we can write it as log of x plus root over x square minus a square. I will write logarithm. Log of log mod x plus means v plus. What is v? Sin x. So, sin x plus root over x square minus a square, that means root over v square minus sin square alpha, that is sin square x minus sin square alpha. Plus c. This is the final answer. Okay. Next question. Integral dx by root over e power 5x into fourth root of e power 2x plus e power minus 2x. We have to rearrange the terms and then try the substitution. How to rearrange the terms? Integral dx by e power 5x is root over e power 5x is e power 5x by 2. Take e power 2x common from this bracket. E power 2x becomes e power 2x whole cube whole power 1 by 4 means e power 2x whole power 3 by 4. Now, what is the remaining fourth root of? One plus, we have taken e power 2x common, so e power 2x becomes 1, this becomes e power minus 4x dx. Now, what is this? E power 3x by 2, e power 3x by 2 into e power 5x by 2 will be this into this, we can add the powers, it becomes e power 4x into fourth root of 1 plus e power minus 4x. 1 by e power 4x is e power minus 4x. So, it is e power minus 4x dx by fourth root of 1 plus e power minus 4x. Now, everything is clear. Derivative of e power minus 4x is e power minus 4x into minus 4. Minus 4 is constant, e power minus 4x is there in numerator. So, if you put instead of e power minus 4x, you can put 1 plus e power minus 4x is equal to t, because derivative of 1 is constant. Its derivative is minus 4 into e power minus 4x into dx is equal to dt. Taking minus 4 to right hand side, e power minus 4x dx is equal to minus dt by 4. Now, over here numerator becomes minus dt by 4 by fourth root of t. 1 by fourth root of t is nothing but t power minus 1 by 4. It is minus 1 by 4 into integral t power minus 1 by 4 dt. What is the integral? Minus 1 by 4 into t power minus 1 by 4 plus 1, that is t power 3 by 4 by 3 by 4. Plus c. Here 4 cancels. Final answer is minus 1 by 3, let us substitute t, into 1 plus e power minus 4x whole power 3 by 4 plus c. That is the final answer. Next question. Integral cot inverse of x square plus x plus 1. First, we split into two integrals. How to split cot inverse of something into two terms? First, convert into tan inverse. If x is positive, cot inverse x is tan inverse 1 by x. So, we write it as tan inverse of 1 by x square plus x plus 1. X square plus x plus 1 is always positive. So, we can write it like this. Now, we write this as tan inverse of x minus y by 1 plus xy. What is the formula of tan inverse of x minus y by 1 plus xy? Tan inverse x minus tan inverse y. We are going to apply that formula. For writing this as x minus y by x plus y, observe the denominator, we should write it as 1 plus xy. 1 is already there. We have to write remaining as a product. Taking x common, you will get x into x plus 1. This is 1 plus xy. So, you can easily identify x and y. You can take x plus 1 and x as x and y. Then we can write numerator 1 as x plus 1 minus x. Then apply the formula. It will be tan inverse x plus 1 minus tan inverse x. And we do not have direct formula for integral of tan inverse x. We have to find it by parts. While integrating it by parts, we have to take second function as 1. This is first function, second function is 1. So, first function into integral of the second is tan inverse of x plus 1 into integral of second function 1 is x minus integral derivative of the first function, derivative of tan inverse x plus 1 is 1 by 1 plus x plus 1 whole square into integral of the second function is x dx minus integral of tan inverse x, same method, integration by parts. Tan inverse x is first function, 1 is second function. So, first function into integral of the second is x minus integral, minus of minus becomes plus. Derivative of first function, derivative of tan inverse x is 1 by 1 plus x square into integral of the second function is x. Okay. Now, we write first this term and this term as it is minus, how to integrate this? It is x by, if you expand you will get x square plus 2x plus 2. Okay. How to integrate this? We have discussed the method for integrating px plus q by ax square plus bx plus c. We have to write numerator in terms of the derivative of denominator. What is the derivative of denominator? 2x plus 2. So, how to write numerator as 2x plus 2? First multiply by 2 and divide by 2, then add 2 and subtract 2, it is over. Okay. Next, this one, derivative of 1 plus x square is 2x. So, we multiply by 2 and divide by 2, then it becomes f dash x by f of x. Derivative of denominator is numerator. What is the integral of f dash x by f x? Log mod f x. So, here x tan inverse x plus 1 minus, if you separate, integral of 2x plus 2 by 2x square plus 2x plus 2 will be f dash x by f x log mod f x. So, minus 1 by 2 log mod x square plus 2x plus 2. Next, minus of minus plus, 1 by 2 into 2 is 1 plus 2 by 2 is cancelled, 1 by x square plus 2x plus 2. We write it as 1 by x square plus 2x plus 2 can be written as x plus 1 whole square plus 1. Okay. Minus x tan inverse x plus log mod 1 plus x square. Half is also there, half log 1 plus x square plus c. What is the integral of 1 by x plus 1 whole square plus 1? Tan inverse x plus 1. So, if you write this as tan inverse x plus 1, solution is finished. Next question, integral dx upon x minus 3 whole cube into square root of x square minus 6x plus 10. Integral dx by x minus 3 whole cube into square root of, we can write x square minus 6x plus 9 as x minus 3 whole square. So, it is x minus 3 whole square, what is remaining there? 10 is there, we have added 9 here, so remaining is plus 1. Now you will easily get the idea. If you take out x minus 3 whole square from the square root, it becomes dx by, if x minus 3 whole square comes out, it becomes x minus 3 because of the square root. X minus 3 into x minus 3 whole cube is x minus 3 whole power 4 into square root of 1 plus 1 by x minus 3 whole square. Okay. Now you put 1 plus 1 by x square x minus 3 whole square as t. Put 1 plus 1 by x minus 3 whole square as, instead of t, it is better, t square is better because square root is also there, we can rationalize it. What is the derivative of 1 by, derivative of 1 is 0, derivative of 1 by x minus 3 whole square is minus 2 by x minus 3 whole cube is equal to 2t dt. Then 1 by into dx, 1 by x minus 3 whole cube into dx will be minus t dt, cancelling 2. Now 1 by x minus 3 whole cube into dx becomes minus t dt by, what is the remaining denominator is x minus 3 into root over t square. What is x minus 3? From here 1 by x minus 3 whole square is t square minus 1. So x minus 3 will be 1 by root over t square minus 1. 1 by root over t square minus 1 into, this is t, root over t square is t, t cancels. Now what is it? Minus integral root over t square minus 1, which is a direct formula. What is the formula? T by 2 root over t square minus 1 minus 1 by 2 into cos h inverse t plus c, or you can write it as a logarithmic function. Leave the answer like this while by writing where t is equal to under root 1 plus 1 by x minus 3 whole square. Okay. You can also try in another way. We have discussed the standard substitution. If the integral is 1 by px plus q into root over ax square plus bx plus c, what is the method? We will put px plus q is equal to 1 by t. Okay. So here if you take x minus 3 is equal to 1 by t, then you will get dx is equal to minus 1 by t square dt. Actually it is px plus q, but that is cube, but let us try this method. Then what you will get? 1 by x minus 3 whole cube is t cube into dx. Dx is minus 1 by t square dt by root over, this is x minus 3 whole cube whole square plus 1 now. X minus 3 whole square plus 1 means 1 by t square plus 1. Now t square cancels here, you will get minus integral, here LCM is t square, root over t square is t, that will go to numerator. So finally you will get t square dt by root 1 plus t square. What is the next step? Adding 1 and subtracting 1 in numerator. 1 plus t square minus 1 by root 1 plus t square. Now separate the denominator and integrate, both are standard integrals. Okay. Let us proceed to next question. Integral tan of pi by 4 minus x by cos square x into root over tan cube x plus tan square x plus tan x. Tan pi by 4 minus x is tan pi by 4 minus tan x by 1 plus tan pi by 4 tan x. Tan pi by 4 is 1, so it will be 1 minus tan x by 1 plus tan x by secant square x, cos square x by cos square x into square root of tan cube x plus tan square x plus tan x dx. See, these are, both the terms are, this and this are in terms of tan x, and derivative of tan x is also present in the integrand. 1 by c cos square x means secant square x. So we put tan x is equal to t. Then its derivative is secant square x dx is equal to dt. So it becomes 1 by cos square x is secant square x dx becomes dt, remaining is 1 minus t by 1 plus t into square root of t cube plus t square plus t dt. The next step is very crucial. We multiply and divide by 1 plus t. Later you will understand why I am doing that. Multiplying and dividing by 1 plus t. Numerator becomes 1 minus t square by 1 plus t into 1 plus t is 1 plus t whole square into square root of t cube plus t square plus t dt. Now I will divide numerator and denominator by t square and also take minus sign common and then divide numerator and denominator by t square. So you will get minus of integral, it becomes t square minus 1. After dividing by t square, you will get 1 minus 1 by t square. Now you must have realized what is the reason behind this step. 1 minus 1 by t square is the derivative of t plus 1 by t. I am going to substitute t plus 1 by t is equal to something z or u. So we need to write the denominator in terms of t plus 1 by t. How to write? You expand 1 plus t whole square, it will be t square plus 2t plus 1, and we have to divide denominator by t square now. Divide this by t and this by t separately. So this by t into, we have to divide this by another t. If t goes inside, it becomes t square. So inside the square root we have to divide by t square. Then you will get root over dividing by t square, it becomes t plus 1 plus 1 by t dt. Now it is minus integral 1 minus 1 by t square by, if you separate t, you will get t plus 1 by t plus 2 into square root of t plus 1 by t plus 1. Derivative of t plus 1 by t is 1 minus 1 by t square. Derivative of t plus 1 by t plus 1 is also 1 minus 1 by t square. So, we substitute t plus 1 by t plus 1 is equal to some z square, because square root is also there, we have to make it rational. So, put t plus 1 by t plus 1 is equal to z. Differentiating on both sides, we get 1 minus 1 by t square dt is equal to dz. Now, this will be minus dz by, this will be z, we have to substitute z square now to make it rational. Derivative of z square is 2z dz. This will be 2z dz. So, 2z dz by, what is this? 1 plus z square, and this one root over z square is z. Now, cancel z. It is a direct formula. Integral 1 by 1 plus z square is tan inverse z. Minus 2 is also there. Minus 2 tan inverse z plus c. Z is square root of t plus 1 by t plus 1 and t is tan x. So, final answer is minus 2 tan inverse of root over tan x plus 1 by tan x plus 1, that is tan x plus cot x plus 1 plus c. Okay. Proceeding to next question. It is a very good question. Integral 2 plus 3 cos x by 3 plus 2 cos x whole square. We have to solve it by rearrangement method. How to modify the function? If you divide numerator and denominator by sin square x, what happens? 2 by sin square x is 2 cosecant square x plus 3 cos x by sin square x is 3 cosecant x cot x. By divide denominator by sin square x, then inside the bracket you should divide by sin x. Then what will be the denominator now? 3 by sin x is 3 cosecant x and 2 cos x by sin x is 2 cot x. Whole square dx. Now, substitution is very clear. What is it? Derivative of 3 cos x is 3 cosecant x is minus 3 cosecant square x. 1 minute. We have divided by sin square x. So, derivative of 3 cosecant x is minus 3 cosecant x cot x plus 3 cosecant x cot x is there. Derivative of 2 cot x is minus 2 cosecant square x. Here 2 cosecant square x is there. So, derivative of this 3 cosecant x plus 2 cot x will be minus of numerator. So, if you put 3 cosecant x plus 2 cot x is equal to t. Its derivative is minus of this numerator 2 cosecant square x plus 3 cosecant x cot x dx will be dt. So, this integral will be integral minus dt by t square. What is the integral of minus 1 by t square? It is 1 by t plus c. Now substitute t. Okay. Next question. If y square is equal to 2x square plus 3x plus 5 and in is equal to integral x power n by y dx, find the constants ABC such that a into I1 plus b into I2 plus c into I3 is equal to x square y. In fact, there is no need of applying integration in this question. Just substitute I1, I2, I3. In is an integral, so I1, I2, I3 are integrals, A, B, C are constants. A into I1 is integral x power 1 by y dx plus b into integral x square by y plus c into integral x cube by y. Dx is equal to x square y. Now, what I will do is, I will just differentiate it. We know that integral is nothing but antiderivative. So, if you integrate and then differentiate a function, you will get the same function. If you differentiate integral f of x dx, what will you get? F of x only. So, differentiating on both sides. Differentiating on both sides, we will get a is constant, it remains as it is, a into, you will get x power 1 by y plus b into x square by y plus c into x cube by y. Differentiating on both sides with respect to x. We will get this, and what is the RHS? You have to differentiate. Y is a function of x, so you have to apply UV rule and differentiate it. X square into derivative of y is dy by dx plus derivative of x square is 2x into y. Now, cross multiply by this y, you will get ax plus bx square plus cx cube is equal to x square y into dy by dx plus 2x into y square. Now, we need to find ABC. For finding ABC, we need to write RHS as a polynomial like this and then compare the coefficients. How to write? We do not know dy by dx, so we have to calculate dy by dx from this function. Differentiating it on both sides, you will get derivative of y square is 2y into dy by dx. 2y dy by dx is equal to RHS 4x plus 3. Okay. So, substitute here y dy by dx is 4x plus 3 by 2, and here we can directly substitute y square plus 2x into y square is 2x square plus 3x plus 5. Now, it is first write first degree term. What is first degree term? There is no first degree term here. Here 10x. Next second degree term. Here the second degree term is 3 by 2 x square. Here 6x square. So 3 by 2 plus 6, how much? 15 by 2. So plus 15 by 2 into x square. Now third degree term. Third degree term is here 2x cube, here 4x cube. So 2 plus 4, 6x cube. Now comparing the coefficients, we get a is equal to 10, b is equal to 15 by 2, and c is equal to 6. Okay. Next question. Integral 1 by x into root over 1 minus root x by 1 plus root x. What to do? When the function is in terms of square roots, usually first we try rationalization method. Let us rationalize numerator. For rationalizing, we have to eliminate the square root. So for that, multiply and divide by 1 root over 1 minus root x. Then you will get 1 minus root x by x into, we have to divide by 1 minus root x, no? Root over 1 minus root x. This becomes root over 1 plus root x into 1 minus root x. Okay. Then it will be 1 minus root x by x into root, what will you get? A plus b into a minus b is a square minus b square. You will get 1 minus x. Now separate into two integrals. 1 by x root 1 minus x dx minus this, in the second one root x cancels. You will get integral 1 by root x into root 1 minus x is root over x into 1 minus x dx. If the integrand is in the form of 1 by a linear term ax plus b into root over cx plus d, what is the substitution I told? Put cx plus d is equal to t square. So put 1 minus x is equal to t square in the first integral. Then minus dx is equal to 2t dt. This will be minus 2t dt dx by, what is x? X will be 1 minus t square. 1 minus t square into, this is root over t square is t. cancel t, then remaining is a direct formula. Let us write it. At the same time, the second one, since 1 minus root over 1 minus x is present, let us proceed the second integral also with the same substitution. Numerator is dx is minus 2t dt, so this becomes plus 2t dt. Then this root x is 1 minus t square, so root x is root 1 minus t square into root 1 minus x is t. Again t cancels. Now both are standard integrals. What is this? Integral 1 by, I removed minus sign by changing this as t square minus 1, 1 by t square minus 1 dt plus second one plus 2 integral 1 by root over 1 minus t square dt. Now this is 1 by 2 log mod t minus 1 by t plus 1 formula plus second one integral 1 by root over t square 1 minus t square is sin inverse t plus c, that is all, where t is equal to root over 1 minus x. Next question, integral x square into e power x sin x dx. It is a product of three functions. We have to integrate by parts. For integrating by parts, we have to select first function and second function. You take x square as first function and e power sin x as e power x into sin x as second function, because we already have the formula for integral of e power ax into sin bx dx and also e power ax into cos bx dx. So this is first, this is second. First function into integral of the second, I will directly use the formula. What is the integral of e power x sin x? Using this formula, e power x by e power ax by a square plus b square. A square plus b square is 1 square plus 1 square 2 into a sin bx plus c means sin x minus b cos bx plus c cos x. First function into integral of the second minus integral derivative of the first function, that is 2x, into integral of the second is e power x by 2 into sin x minus cos x. Okay. First term as it is, here 2 cancels, again it is a product of two dissimilar functions. So take x as first function, remaining as second function, and integrate by parts. I will first write separately x e power x sin x dx minus of minus plus integral x e power x cos x. Okay. This is as it is minus first function is x, second function is e power x sin x. So x into integral of the second e power x by 2 into sin x minus cos x minus of minus is plus derivative of the first function is 1 into integral of the second function is e power x by 2 into sin x minus cos x dx, and similarly integrate this. Okay, integrate this, and now you can integrate the last part that by using this formula and the e power ax into cos bx formula. Okay. And one more question, I will explain the procedure, you try. Here cos 2 theta into, you can write this as 1 plus tan theta by 1 minus tan theta, dividing numerator and denominator by cos theta, you will get 1 plus tan theta by 1 minus tan theta, which is tan pi by 4 plus theta. Now, these two are dissimilar functions, one is trigonometric, another is logarithmic. So, what will you do? Integrate by parts by taking logarithmic function as first function, cos 2 theta as second function. Integrate by parts, you will get it. Okay. Now, I am going to take up some doubts just after 1 or 2 minutes break. Hello students, welcome back. Now, let us take up the question asked by someone. If y into x minus y whole square is equal to x, it is not visible to you, it seems, so I will write it again. Y into x minus y whole square is equal to x. Then integral dx by x minus 3y equals, 4 options are given. First option, half ln x minus y whole square plus 1. Second option, half ln x minus y whole square minus 1. Third option, 1 by 4 ln x minus y whole square plus 1, and last option, 1 by 4 ln x minus y whole square minus 1. 4 options are given. Let us proceed. This integrand contains x and y both, and also it is not possible to find y and substitute here. So, we have to modify this. How to modify? You can see the options, every option is in terms of x minus y. So, we have to write this whole thing in terms of x minus y, and at the same time you should get d of x minus y. Okay. So, let us try. If you differentiate this on both sides, how to differentiate? In differentiation you have a formula, dy by dx is equal to minus dou f by dou x by dou f by dou y, minus of partial derivative with respect to x by partial derivative with respect to y. That can be used for implicit functions. It is useful more in implicit functions. What is an implicit function? If the relation between x and y is given in a mixed form, indirect form like this, it is called implicit function. Now, dy by dx is equal to minus of partial derivative with respect to x. So, y is constant. So, y into derivative of x minus y whole square is 2 into x minus y. Okay. And x is also there, take it to a left hand side, it is minus x, its derivative is minus 1 by partial derivative with respect to y. it is product rule, 1 into x minus y whole square plus y into 2 into x minus y into minus 1. So, it becomes minus 2y into x minus y, and derivative of x is 0 because we are differentiating with respect to y partially. Now, you can take x minus y LCM in the denominator, x minus y into what is remaining, x minus y minus 2y, it will be x minus 3y, and numerator is minus of 2xy minus 2y square minus 1. What is our idea? To write everything in x minus y, and also instead of dx we should get d of x minus y. Let us find d by dx of x minus y first. D by dx of x minus y is what? D by dx of x is 1 minus dy by dx. So, first multiply both sides by minus sign, then you will get minus dy by dx is equal to, this becomes plus, then add 1. 1 minus dy by dx can be written as d by dx of x minus y is equal to, take LCM, x minus y into x minus 3y, and numerator will be, it is better to write this as 2y into x minus y only because we want to write everything in x minus y. So, keep that as 2y into x minus y minus 1 plus x minus y into x minus 3y. Now, taking x minus y common from first and last terms, you will get x minus y into, what is the remaining? 2y plus x minus 3y, that is also x minus y. So, it becomes x minus y whole square plus 1 upon x minus y into x minus 3y. Now, cross multiplying dx and take this terms of x minus y to left hand side, then you will get dx by x minus 3y, dx by x minus 3y is equal to x minus y by x minus y into d of x minus y by x minus y whole square plus 1. Now, integrate on both sides. This is the given integral. It is equal to this integral. Just like assume that x minus y is t, integral t dt by t square plus 1. How to integrate? Multiply and divide by 2. Integral t by 1 t square minus 1 dt is what? Multiplying and dividing by 2, it becomes f dash x by f x. Derivative of denominator is numerator, its integral is log mod f x. So, its integral will be half log mod denominator, that is x minus y whole square minus 1 plus 1, no? Yeah, it is minus 1. Okay. So, answer is which option? Option B. Correct answer is option B. Okay. Now, We have very limited time, about half minute. So, I will explain the next doubt, just procedure you can try. Next doubt please. Yeah. In this question, as it is, we cannot integrate because what is f of x we do not know. Using the given relation, what is the given relation? If x f of x is equal to 3 f square x plus 2, we have to find 2x square minus 12x f of x plus f of x by 6 f of x minus x into x square minus f of x whole square. And we have to modify the integral just like previous question by using this given relation. If you differentiate on both sides, you will get x f dash x plus f of x is equal to 6 f of x, 6 f of x into f dash x. Then from these two, if you take f dash x common, you will get 6 f of x minus x into f dash x is equal to f of x. Okay. Now 6 f of x minus x is in the denominator. So what will you do? In the numerator also, if you take 2x common from the first two terms, you can get this. Okay. So there you can substitute this result and then manipulate so that this will cancel out. Here you can write f of x as this here. If you write f of x as this, then 6 f of x minus x will cancel out, then you will easily get it. Okay. So try yourself. I am going to close the session for today, and in the next class we are going to start a new topic. We are going to continue parabola. We are going to start parabola coordinate geometry. Okay.